Did anybody join for doubt solving class from the batch? No? Okay. Where were we in the last class? Did we do total internal reflection?
Yes, we completed condition.
Did we do reflecting prism, deviation of ray by 90 degree, deviation of ray by 180 degree, erect the inverted image without deviation? We did that, huh? Erect the inverted image without deviation. Okay. So we completed the application of total internal reflection for 45 EIR for 45 degree, 90 degree, 45 degree prism, right? Right angle prism, this we did. This we completed, right? What applications did we complete here? Deviation by 90 degree. This application was in periscope, right? Everybody remembers it? Then what did we do in the second application was binoculars and cameras. Which deviation was that?
180.
Yes, this was 180 degree. This was in case of binoculars and cameras. I think you did not attend, right? You were on leave or something?
Yes.
You did not attend quite a few lectures, I think. But you went through the video lectures?
So nothing was getting on the videos. The voice was
Not, not audible properly?
Yes.
Is it so? Like what? It was muted or it was not?
No, sound was not coming properly and I was in village, so network was also not.
Okay. So try again in Mumbai.
Yes.
So I think audio may be an issue, but video will be clear.
Yes.
Right. Third. Anybody else also had, because last time I asked, they said they're getting, the video is okay, right? So the sound was okay? So maybe it depends from class to class. Like sometimes I'm taking your class here, sometimes the other room. Okay. And the last one was, so no deviation. So inverted without deviation. So where is it used? The last case, inverted, image is inverted without deviation. It is used for slide projector, right? Slide projector. So this is where we stopped in the last class. So there are some more applications of Prism. This time it is for different prism, right? So TIR in case of equilateral prism. So what is equilateral prism? All angles are 60 degrees. All the angles in the prism are 60 degrees. That is equilateral. So this is 60 and 60. So in this case, let us see what is the angle of deviation, right? So what is the deviation now? Let us say the angle is the incident ray is along the normal at this point. Right? So this is incident along the normal, so this is 90. Okay, because it will go undeviated. So this is 60. So what is this angle? 30. Okay. So what is the angle of incidence at this point? This is 30, so this should be 60. Angle of incidence is 60. Is it greater than critical angle? What is critical angle? Critical angle is the what is critical angle?
Angle of incidence.
Which is for glass it is 42 degrees, right? So it is 42 degrees for Icse is equal to 42 degree for glass. And what is critical angle? Whenever light is incident at critical angle, its angle of refraction is 90 degree in the other medium. And is this critical angle or greater? Greater. So whenever light is incident with an angle greater than critical angle, and 60 is greater than 42, then what would happen? Total internal reflection, right? So now the light will be internally reflected. So now this also should be 60 then. Therefore this should be 30. This is 60, 30. So this is 90. Therefore it will come out straight. Correct? It will come out straight. So what is the angle of deviation now? This is the emergent ray. What is angle of deviation? This is incident ray. So angle of deviation must be this angle. Right? So what are these angles? This is 30. This is 30, right? So 60 plus 60, 120 plus 30, 150. And this is linear pair. So 150 minus 180 minus 150, this also should be 30. So 30 plus 30, angle of deviation is 60. Okay. So the angle of deviation in this case is 60 degree. So where do we use it? In various optical devices, right? So the question is, There could be a question. Draw the ray diagram for total internal reflection by a prism which gives you angle of deviation 60 degree. Then you have to actually draw this. Okay? So, in case of equilateral prism, right, angle of deviation is is 60 degree. Okay. Next case. Next is TIR. Okay, let's write it here. Next is 30 degree, 60 degree, and 90 degree. Next prism is this. This is also right angle prism, but the other two angles are 30 and 60, not 45, 45. So this is the third type of prism we are going to study, right? So this is, we have 30 degree, 60 degree, this is 30 degree, this is 90. The other right angle prism was where both other angles were 45, 45, the first case, right? So how do we study angle of deviation in this case? So let us say, so everywhere what we are doing, we are making the incident ray normal, right? Along the normal. So this is the trick, right? Unless in case of 45 degree, how it was? So in two cases, it was normal only, first and second. Deviation by 90 degree, deviation by 180 degree. So it is along the normal only. Only in the third case, okay, it is not normal. Okay, so you have to remember this. In inverted case, it is not normal. Everywhere else, the incident ray is normal, right? Right? You see that? Okay. So if it is incident along the normal, so how will it go? Straight. What is the angle of incidence now? This is 90. What is the angle of incidence on this surface? So draw a normal there. If this is 30, this is 90, this must be 60. So this must be 30. So what should happen at this surface? Will it cause total internal reflection? No. So it should be refracted. So it will go away from the form. Yeah. So what is this angle of refraction? So what is the angle of deviation? Right? Obviously it is greater than 30 degree. So this is the angle of deviation. This. Right? The emergent ray, have I drawn it correct? गलत हो गया. So I have drawn the second case. This diagram is not correct. Okay, this should be normal. It is not tilted. So whenever, so there is no TIR. This is a case of refraction. No TIR. So when it is perpendicular on the or an angle opposite 60 degree, okay, there will be no TIR because angle of incidence is less than critical angle, right? There is one more case when there is no TIR. If it is incident from the opposite side, this side, let's check that. So there are two cases where there is no TIR. This is 60. This is 30. This is 90. It will come here straight. If this is 90, what is normal? So normal is this, angle of incidence is always with normal, right? So this will be 60 then. So this will be 30. So again it is less than critical angle. So it will be just refracted. Okay, so no TIR. No TIR. So whenever the rays are incident normally on the bigger length of the prism, there is no TIR. This is how you have to remember it. Okay. Now let's see what happens if it is incident normally on the smaller face. Right? See the first diagram. So what is happening now? Okay. So there is an exception for this. Exception. What is the exception? So exception is if the ray is made to fall within this. Let us say draw a perpendicular from here. If the ray is incident anywhere in this region, then there will be a TIR. Okay, let's see. So if you have this situation. What are we doing? We are drawing a perpendicular from the 90 degree. If the ray is incident within this part, and where will it go? It goes right. So this is 60, this is 90. So what will be this? 30. What is the angle of incidence? 60. Okay, so now there will be total internal reflection. So what is this? This is just imaginary, right? So when we on this face AC, here we saw that it is not suffering TIR. But if this ray on AC falls within this distance, within the foot of the perpendicular from the right angle, then it will suffer TIR. Okay, so now this would be 60 again. Right, this is 60. Now draw the normal here. So if this is 30, this is 60, this is 60, this must be 30. Now the angle of incidence is 30. So therefore, no TIR, it will be refracted. Away from. Got it? So any ray incident on face AC within the foot of the perpendicular from the right angle will be totally internally reflected from the bottom face. But then that reflected ray will suffer refraction at the face AB. Now what is the angle of deviation? So this is the incident direction. And the deviation is this. Right? This is the angle of deviation. So can you find out how much is that? How much much is the deviation? So you just find that out. Now see, this is 30, right? Okay. This is the incident direction. This is refractive. So count the angle. Anybody has the textbook? Just give me the textbook. So the incident ray gets deviated to an angle greater than 60 degree. This angle of deviation obviously is greater than 60 degree. Okay, just write deviation greater than 60 degree. So this causes deviation equal to 60 degree. So in this situation, the deviation is more than 60 degree. Just remember it that. Geometrically, you just verify. Okay, in free time. Then what is the deviation through less than 60? So this was the deviation through more than 60 degree. And now let's figure out what is the deviation through less than 60 degrees. So this is the first option in the book in your volume. So you have 30, 60, 90. So far the ray was incident from the bigger lens. Now the ray is incident from the base. Okay. So when the ray is incident from the base, like this, along the normal. So everywhere the incident ray is along the normal only, wherever you see it, right? So then it will reach the other end. So what is the angle of incidence? This is 60, so this is 40. This should be 60. This also should be, so 60 is greater than critical angle. So it will suffer TIR over here at this point. So 60. So what about this? What is the angle of incidence? What will be this angle of incidence? Now see, if we extend it over here, this would be 60, this is 90, right? So what will be this? 180 minus 60 is 120, right? This would be 30, 150, so this must be 30. Correct? So is the angle of incidence greater than critical angle? No. So what should happen? Yeah. So it will be away from it. So what is the angle of incidence then? So this is the incident direction. So this direction. What is this angle? So if this angle is greater than 30, right? So it should be like less than 60. So this is angle of deviation. This is angle of deviation, right? Because this is the incident direction, same parallel, isn't it? Right? So what is angle of deviation? Angle of deviation is less than 60 degree. Right? How do I verify? So when I apply sin I by sin r over here, so sin I is sin 30 upon sin of r. So for glass and air, so what is the refractive index of air with respect to glass? This will be 1 by 1.5. Okay, so when you calculate this, you can find. So this gives sin of r will be equal to 1.5 times sin 30. How much is this? How much is sin 30? 1 by 2. So this will be 1.5 into 0.5. How much is this? 2. 75, right? 0.75. So sine of r is 0.75. Therefore, what is r? Therefore, r is equal to sine inverse. Now, this you are yet to learn. Have you learned what is inverse function of sine in your SCS? Have you learned about inverse function of sine? So, from the just like log tables, you will find what is the angle of reflection for which sine value is 0.75. So, from the table you can find out. Okay. So, I will tell you from the calci. So, you have sine inverse function, right? Sine inverse 0.7. So, angle of refraction is 48. Okay. So, if this is 48, then 90 minus 48 is how much? This is angle of refraction you are getting as 48 for this. So, if this is 48, then what is angle of deviation? 42, which is less than 60 degree. Got it? So, this is what we have. Angle of deviation is less than 60 degree. Okay, so here we have to use the mathematics and we have to know what is the refractive index of glass with respect to air, right? And here it is opposite of Snell's law, because now when we apply Snell's law at this, right? What is it? Air with respect to glass. That will be 1.1 upon 1.5. Okay. So with this we have covered all cases of total internal reflection and taking place in case of prisms, right? And the last topic is difference between total internal reflection and ordinary reflection. Just open page 64 in your volume. So what is the difference between total internal reflection and ordinary reflection? What are the two conditions for total internal reflection?
Angle should be greater than critical angle.
In the rarer or denser medium?
Rarer medium.
From
Denser.
denser.
So TIR is a phenomena specific to ray traveling from denser medium to rarer medium. Okay, so you have to keep this in mind. Very, very important. Okay, so that's it. So it takes place when ray travels from denser to rarer medium. Ordinary takes place in any medium. Okay, at the surface, reflecting surface, it takes place in any medium. Second condition is it takes place only when angle of incidence is greater than critical angle, even when the ray is in the denser medium. Okay, an ordinary reflection takes place at any angle of incidence, right? Right. And in case of total internal reflection, 100% energy is It should have been reflected. It's just corrected. 100% energy is reflected, not transmitted. Transmitted में तो refract हो गया. Give me a And in case of reflection, there is a loss of energy because some of it is absorbed by the reflecting medium. Okay. ठीक है? Okay. So are these ray diagrams understood by you? What I suggest is in your book, just mark all these notes, additional notes. Okay. Just make some correction in your volume. Like this diagram is not correct. This should be perfectly perpendicular on face AB. Okay. So I have drawn this diagram last. Look here. This diagram is last. Okay, over here. The first diagram in your volume is this diagram. Then A and B is this A and B. Right? Let me label it. So this is A, this is B. Only in these two cases there is no total internal reflection. Then this is the last diagram and this is the first diagram. So with this, we are through with refraction of light at plane surfaces. So if you have any questions, you can ask me. Questions are very simple, previous board, right? You can try it yourself. What I will do is, I will go on to Classwork numericals on page 71. Anybody has any question here? Only thing is, where TIR is happening, where the angle of incidence is greater than critical angle. Okay, only this thing you have to do. Alright. Can I erase these diagrams? Have you taken notes in your volume? Have you written all this in your volume? This you need not write. You just remember that in this case the angle of deviation will be less than 60. Okay, because we calculated R to be 48 degree for this. Okay. So previous board question, if you look at the first question, complete the path of monochromatic light ray AB incident on surface Q. So this is page 64. So we have already done this in theory, right? How should be the ray? The ray in the prism will be parallel to the base, right? It will be parallel to the base. And when it comes out, it will bend towards the base further. So we have already covered this in theory. Okay? So these are all theory based. The second question we discussed just now, right? The second last diagram. So whenever it enters, then it will be totally internally reflected, and then it will be refracted from the last. Right? This was second last, greater than 60-degree deviation. Remember? This one. So whatever we discussed just now. Okay. So likewise, you should be able to do it yourself. Okay. So let us move on to page 71. All these questions are very easy. Okay. If you come across any difficulty, ask me in the next class or during the doubt solving. Let us do the classwork numericals on page 71. Classwork numericals. So now, since this is a short class, I think I will help you do this. So the speed of light in air is given as 3 into 10 raised to 8 meter per second. Calculate the speed of light in glass. So what is speed of light in glass? Is equal to what? The refractive index of glass is 1.5. Given refractive index of glass is equal to 1.5. What do we do? So since now this is the absolute refractive index of glass, this is defined as speed of light in air divided by speed of light in glass, right? By definition of absolute refractive index. So what is VG? This is by definition of absolute refractive index. Already covered in theory, so this will be G C by refractive index of glass. How much is this? 8. So this is what I used. The refractive index of glass is 1.5 in the previous diagram. Remember? You have to remember this well. For water, it is 1.3. So you will solve so many numericals. So these things will be automatically memorized by you. Okay. Provided you solve so many numericals, right? So what this will be? So this is 30 by 15 into 10 raised to 8, which is 2 into 10 raised to 8 megajoules. Easy. Now, next question. Question 2. All of you okay with question 1? So, question 2. Monochromatic ray of light strikes the surface of transparent medium. At an angle of incidence 60 degrees and gets refracted into the medium at an angle of reflection. What is the refractive index of the medium? So, what is refractive index? Sine of I upon sine of R. So this is how it is, right? So given what is the angle of incidence? 60 degrees. Angle of refraction is 45 degrees. And in the question itself, it is given sine 60 is, make a correction 0.866. What is given in the book is just 0.866. And sine 45 is 0.707. So when you solve this, you should get 1.22. So this was straight formula substitution. Right? You can do it with this method also. What is sine 60? Root 3 by 2. What is sine 45? 1 upon root 2. Right. So root 2 will, this will be root 3 by.
So sine 45 is 1 upon root 2.
Yeah, so 1 upon root 2 will go up, no?
Yes.
Okay. So this will be root 3 by root 2. So when you basically simplify, you will get this only. Right? So how much is 1 point, what is root 3? 1.7 something, right?
7.
This is 1.4. So when you divide 17 by 14, you will get 1.22. Right? So either which way, either you do with the given way or this way, whichever you find simpler. Right? So this is or alternately. Or this. Somebody singing there. Good. So when you're fully concentrated, sometimes these things happen. Okay. So what is given? A coin is placed at the bottom of a beaker. Is everybody done? Question 2. Question 3. Coin is placed at the bottom of a beaker containing water. So water's refractive index is given to you. 4 by 3. This is the refractive index of water. Where is the coin placed? So real depth is of the coin is given as 12 centimeter. This is equal to 0.12 meter. By what height the coin appears to be raised when seen from vertically above? So height raised is real depth minus apparent depth. So height raised is real depth minus apparent depth. Right? And what is apparent depth? Apparent depth is real depth divided by mu w. Correct? We have done this. Correct? So what have we done? This is the point. This is real depth. The point is placed. But it appears to be at this height. This is your apparent depth. Right? So this is your height by which it is shifted. H is equal to d minus e. Right? And this small d is given as capital D by mu water. We have done this in theory. So this is the shift. The shift of point. Okay, is H. So how much is this? This is d 1 minus 1 by mu w. What is the? There is 0.12. 1 minus 1 by 4 by 3. So 4 by 3 is 0.12. 1 minus 3 by 4. So this is 0.12 into 4 minus 3, 1 by 3. 0.03 meter or 3 centimeter. So the coin will shift up by 3 centimeter. So are you all understanding or simply writing? Who can explain me question 3 after writing it? So what is H? Shit. Oh, wow. So where is coin lying? It is lying at the bed or the bottom of the wheel. But when the observer sees it from outside, to him it appears as if to him it appears as it is here. Speed there. Okay? The rays are going away. Right? So he feels that the coin is here, not here. Correct? Have we covered this?
Yes.
So, coin actually moves up as felt by the observer outside due to refraction of light. Okay. Any questions still here? Anybody? Everybody understood? Am I going too fast? Still some of you are right. So if you don't respond to what I'm asking, I'll start singing. Thinking nobody is here. Okay, question 4. Somebody read it for me. Chalo bhai, you read it. They're both enjoying it.
A ray of light incident at an angle 72 degree on an equatorial prism gets deviated through an angle 45 degree on passing through the prism. Calculate the angle of emergence of the ray.
So what is given is we played snake game when you were not here, right? Do you have any idea what is snake game? No. Okay. So snake game is there is a snake on which everybody was sitting. So snake was giving a ride to everybody. Okay. And then it was taking alternate various stops, right? जहाँ पे snake रुकता था, that rider used to come on board and solve the numerical. Okay, so you basically saved yourself. So chalo. So right now I'm the only rider on the snake. Okay, that's why I'm solving it. Okay, so the ray of incident light. What is angle of incidence? I is equal to 72 degree, right? So this is angle of incidence. Then what is given? It is deviated through an angle of 45. What is angle of deviation? So this is angle of deviation. And this is given to be 45 degree. Okay. Calculate the angle of emergence of the ray. So what is angle of emergence? You draw the normal here. So this is angle of emergence. Right? So what is given is deviation is equal to 45 degree. You have angle of emergence is equal to okay. So what is the relation between angle of incidence, angle of emergence? Here it is calling as I2. Right? What is the relation? I plus E is equal to delta plus A. Now it is given that it is equilateral prism. So it will be 60. So this is I or E is equal to delta plus A minus I. So delta is 45, A is 60, I is 72. Okay, so angle of emergence is I2 as per your book. Have we done this relation
Yes.
for equilateral prism? Right? So since it says equilateral prism, it is given in the question, equilateral prism. So you have to understand that A is equal to 60 degrees. That's it. So how much is this? This is 105. So 105 minus 72.
33.
So this is 33. So degree Celsius लिखते हैं. Angle of emergence is 33 degrees. That's all. Yes. Okay. Next question is a related question. Let me do it over here only. So question 5. At minimum deviation I is equal to E. From this equation, therefore 2I is equal to plus A. So the same formula becomes this at minimum deviation. For the next question. Right? So what do we have? What should be the angle of incidence for a ray of light which suffers minimum deviation of 36 degrees through an equilateral prism? So for 2I is equal to 36 plus 60. So that's much 96. Therefore, y is equal to 2 4s are 48. So this is 48. Right? Everybody got it? These two questions are related because it says at minimum deviation. So the same formula gets modified like this. So how much more time we have? 3 minutes. Right? Next question. Shall we discuss next question? The refractive index of water with respect to air is 4/3. What is the refractive index of air with respect to water? So question 6. What is given? Refractive index of water with respect to air is given as 4/3. Therefore, refractive index of A with respect to W is equal to what? Isn't it reciprocal of above?
3.
Correct? We have done all these things, right? So it will be 3/4. So 3. So this is equal to 4/3. Ah, sorry, 4/3. 4/3. So how much is this? This is 0.75. Next is application type classwork. So draw the diagrams to show the refraction of light air to glass, glass to air. In each diagram, label the incident ray, refracted ray, angle of incident, angle of refraction. Can you do this? So homework questions you will try. We will discuss some application type question in the next class. I entered the class little late, right? And this is your last class. So let's discuss few classwork. Anybody has to catch any train or something? No, no. So
Last class, chemistry.
अच्छा तुम्हारा एक chemistry class है क्या? तो ठीक है 3-3 घंटे तुमने attend किया. So you are now okay. Let's discuss 2 more questions from the application type. So first one we have already covered in theory, right? Whenever the ray enter from air to glass, it will bend towards the normal in the denser medium, right? And when it goes from glass to air, it will go away from the normal, right? That is what. And then you have to label, right? Question 2. Light ray passes from water to air glass. In each case, how does the speed of light change? Passes from water to air. What should happen to the speed of light? Increase or decrease? Increases and moves away from the normal. And from water to glass, decrease because glass is denser than water. So when it decreases, it will bend towards the normal. Very good. Third question. In the given diagram, name the ray which represents the correct path of light while passing through the glass block. Air to glass. Which one it will be? Leave it. It's harmless. It is harmless. Yeah. B. Everybody with B? Right? Okay. Why not A? Why not A? So A is crossing the normal. It can bend towards the normal, but it can never cross it. So A is like going even, it's crossing the normal, right? So that's not allowed. So it can bend towards the normal, but not cross it. So A is invalid. B is the only correct option. C is undeviated, not possible because density is changing. And it can't go away because it is a denser medium. Okay, so only option is B. All right. Okay, so 4 onwards we'll discuss in the next class. Right? See you in the next class.
क्वेश्चन हमने बोला था ZX फिटनेस नहीं करने
Exactly.